This video explains the Copernican Revolution. By continually adding epicycles, astronomers were able to fit observational data acquired for over 1,500 years to Ptolemy's model, and by the 16th century the following paradigm had developed. Man is God's special creation of the physical universe. The earth is the center of the mathematically planned universe, and we are given the gift of reading this harmony. The ideal Greek of finding logical, systematic explanations to physical events was rediscovered and celebrated. And along with this came unbounded faith in the new power to reason and solve physical problems. The Renaissance era had started. The Renaissance era also made use of Occam's razor, which started more around the 1300s. It was a principle which stated that the best model is the simplest one, the one requiring the fewest assumptions and modifications in order to fit the observations. This was used when you had to choose between two or more models that accurately explain the observations, or explain them all about as well. Guided by Occam's razor, some scientists began to have serious doubts about Ptolemy's geocentric model in the early days of the Renaissance. Copernicus was one of those astronomers. Copernicus was a German mathematician and astronomer who formulated a heliocentric model of the universe. His book on the revolutions of celestial spheres was published just before his death in 1543. Copernicus marks the beginning of the Copernican Revolution and, more importantly, the scientific revolution. Copernicus realized that the solar system was heliocentric, centered on the sun. Planets exhibit apparent retrograde motion due to their distances from the Earth and orbits around the sun. In Copernicus's mind, he felt that any model of planet motions must account for the observations and have circular uniform motion. Numerous sub-epicycles and offsets had made the Ptolemaic model very complicated, and he thought surely God would have wanted a cleaner, more elegant universe. He was strongly influenced by Neoplatonism, which was the belief that combined elements of Christianity and Platonism. This led him to believe that the sun was the material copy of God. God was the creative force sustaining life, and the sun gives us warmth and heat. He adopted Aristarchus's heliocentric model because he felt that God should be the center of the universe. The Copernican model had the same accuracy as the revised Ptolemaic one, but it was much more elegant. He regarded his model as reality. Others regarded it as a less complicated practical model, but clung to the belief that Aristotle's model or cosmology was the correct and accurate picture of the universe. Copernicus retained the Aristotelian notion that planets fulfill the goal of perfect circular motion. He used small epicycles to get the details of retrograde loops correctly, and then he used trigonometry to describe the distances of the planets from the sun relative to the astronomical unit, the average distance between the Earth and the sun. But he did not know the numerical value of the astronomical unit. He found that the planets farther from the sun moved slower, and that different speeds of planets around the sun provided a very simple explanation for the observed retrograde motion. So his assumptions were that there is no one center of all celestial circles or spheres, and that the center of the Earth is not the center of the universe, but only the gravity of the lunar sphere. So he understood that the moon was going around the Earth. All the spheres revolve around the sun as their midpoint, and therefore the sun is the center of the universe. The ratio of the Earth's distance from the sun to the height of the firmament, that was the outermost celestial sphere containing the stars, is so much smaller than the ratio of the Earth's radius to its distance from the sun that the distance from the Earth to the sun is imperceptible in comparison to the height of the firmament. Whatever motion appears in this firmament arises not from any motion of the firmament, but from the Earth's motion, and the Earth, together with the circumjacent elements, performs a complete rotation on its fixed poles in a daily motion, while the firmament at the highest heaven abide unchanged. What appear to us as motions of the sun arise not from its motion, but from the motion of the earth and our sphere, with which we revolve around, like the sun around any other planet, and then the earth has then more than one motion. The apparent retrograde motion and direct motion of the planets arises not from their own motion, but from Earth's. And so he introduced this concept of frames of reference to talk about apparent motion, and frames of reference become very important in Galileo's work, in Newton's work, and later in Einstein's work. This is a picture of the Copernican cosmology showing the sun at the center, and around it Mercury, Venus, Earth, with the moon going around the Earth, Mars, Jupiter, Saturn, and then the immobile stars. So what he saw is not too far from how we usually draw the solar system in grade school. The Copernican Revolution was strongly influenced by this Neoplatonism. So again, we should emphasize that he adopted Aristarchus's heliocentric sun model because he felt that God should be at the center of the universe. So he wasn't devoid of religious thinking. He just had a different way of viewing it. He published this book on his deathbed, dedicated it to Pope Paul III, who accepted the dedication. For philosophical reasons, Copernicus clung to the belief that all the orbits of celestial bodies must be perfect circles, and to the belief in the unobserved crystalline spheres. He had to retain the Ptolemy's complex system of epicycles and account for the observed deviations from circularity, and to square his calculations with observations. Copernicus's model had the same accuracy as the Ptolemaic one, but it was much more elegant. It is a myth that Copernicus's heliocentric model was more accurate than the previous geocentric model, and a myth that it was much simpler, and a myth that the center of the universe was the most important place in the geocentric model. Aristotle, after all, had placed the prime mover on the outermost sphere. It is a myth that Copernicus feared publishing because the church, in fact, was encouraging him to publish. It should be noted, though, that another author put a foreword in this book or publication saying, kind of a disclaimer, saying that it was a mathematical scheme of convenience, but not a picture of reality. But it is a myth that Copernicus thought the system was just a handy mathematical device and not reality, because he held a deeply philosophical reason for heliocentrism. And it's a myth that Copernicus' system was quickly accepted by other astronomers. Well, why was it difficult for these astronomers to accept? After all, it explained why the inner planets, Venus and Mercury, were always found near the sun. It explained why Mars, Jupiter, and Saturn are closest to the Earth and are opposite the sun in the sky. It explained retrograde motion as an apparent motion and not a true backward motion, and the phases of Venus. But it couldn't explain a few other things that they simply weren't ready to understand. It couldn't explain how a rotating Earth with a point on the equator of about 1,000 kilometers per hour would not be felt, or this orbiting Earth going around the sun at 100,000 kilometers per hour would not be felt. So they didn't have an understanding of inertia, which is what Galileo gave us. They couldn't explain the lack of yearly parallax in stars, that is, the closer stars shifting a little bit with respect to the background of more distant stars. They also had historical religious doctrines that stated that the Earth does not move. And at this point in our time, the church was heavily invested in maintaining a cosmology that was consistent with its historic beliefs. So this ends the lecture on the Copernican Revolution and this learning module.